In this class, we're going to treat acids and oxy acids as if they are ionic compounds. One of our definitions of acids is that it produces a hydrogen ion in solution. So the majority of our chemical formulas for acids will start with an H. Now, we can have some binary acids and then we can have some polyatomic acids as well. And what happens is the H satisfies the charge of the anion. So if our anion is the chloride anion, it's a -1, hydrogen is a +1. They have equal and opposite charges, so the chemical formula for this compound would be HCl. Again, remember, capitalization matters in chemistry. So the C is capitalized, but the L is lowercase. This is called hydrochloric acid. When we name a binary acid, we have hydro for the H, chlor is the root of the anion, and then we have an ic acid. So similarly, if we had a bromine anion, then we satisfy that charge with a hydrogen. We form what is called hydrobromic acid. If we have HI, this would be hydroiodic acid. So again, that's hydro, the nonmetallic root element name, then ic acid. Now we can also have a polyatomic acid that's named in a similar way. So if we have cyanide, and cyanide is a -1, so it would only have one hydrogen, then this would be named hydrocyanic acid. If our polyatomic ion has an oxygen, however, we have to use our oxy acid naming conventions. So what we do is note that we're either going to start with something that ends in ate or something that ends, well, now that should be a 2, something that ends in ite. So here we have nitrate and nitrite. They both have a -1 charge, so they're each only going to need one hydrogen. When we make it an acid like this, we would name the acid that is built off of the nitrate, we would name that nitric. So we replace the ate with ic and add acid. So this is nitric acid. For the nitrite, we're going to call this nitrous. So we're going to replace the ite with us and add acid. If we were to start with phosphate, note how phosphate has a 3-. That means we're going to need 3 hydrogens in order to satisfy that charge. So H3PO4, because this was phosphate, we're going to call this, we're going to remove the ate and add ic acid. So this is phosphoric acid. If we were to start with carbonate, carbonate is CO3 2-. So in order to satiate those charges with hydrogen only, it would be 2 hydrogens to satiate that charge. So H2CO3, and carbonate becomes carbonic acid. Now here's the tricky part with oxy acids, and what we're going to do is we're going to start with chlorate. This is chlorate. Now some oxy acids can form more than one compound, and we do that by either adding or removing oxygen, and it makes different compounds. So although this is chlorate, so if we were to add a hydrogen to satiate that charge, this would be chloric acid. If we remove one hydrogen from it, we form chlorite. So it should come as no surprise that this is then chlorous acid. But we can even add and subtract from here. So if I remove one more hydrogen, then when I form an acid from this ion, then I have to put a hypo here. Hypo means I have one less oxygen than my chlorus. So this is hypochlorous acid. If I add an oxygen to chlorate, I end up with this anion. If I put a hydrogen in order to satiate that charge, then I use the per prefix. So this is perchloric acid. So the ic acid, that starts with my 8 anion. The us acid starts with an ite anion. The hypo is used when I have ite minus an oxygen. Then we use hypo. We use per when I have 8 plus an oxygen. So these oxy acid rules can be tricky, but the chlorate anion is what we use most in order to display this rule.